At first, the design looks simple. A viewer presses play, and one distant origin server sends the video directly to the device. With only a few users, this approach appears to work perfectly. The problem begins when the same title suddenly becomes popular worldwide. Thousands of viewers request identical, high bitrate video segments from the same origin, and its available bandwidth starts disappearing quickly. Infrastructure pressure now becomes a visible user problem. The next video segment arrives late, playback stops, and the viewer sees a buffering spinner instead of the content they selected. A scalable design makes one crucial separation. Lightweight playback decisions stay in back-end services, while the heavy video bytes travel through a dedicated content delivery network. When the app opens, its request enters through the API gateway. The authentication service validates the session and subscription. Then the recommendation service returns personalized title metadata, not the actual video stream. Now the viewer selects a title and presses play. The playback service checks the subscription, regional rights, device capability, and content availability before preparing a valid streaming session. The movie was prepared long before this request arrived. An encoding pipeline creates multiple quality levels, splits each version into short segments, and stores those encoded files in origin storage. The playback service does not return the complete movie. It returns a manifest containing available qualities, segment order, and CDN locations. The player uses this map to request one small segment at a time. The manifest directs the player toward a nearby, healthy CDN edge. The viewer no longer fetches every segment from a distant origin, which reduces network distance, startup delay, and transit cost. If a popular segment is already stored at the edge, this is a CDN cache hit. The edge returns the video immediately, and the origin performs no work for that request. If the segment is missing, the CDN fetches it once from origin storage, saves a local copy, and forwards it to the viewer. One cache miss now prepares many future cache hits. When the network slows down, the player protects continuous playback before perfect resolution. It requests a smaller next segment, then moves back to higher quality when bandwidth improves. If the nearest CDN edge fails, playback can move to a secondary edge. Meanwhile, play, pause, and buffering events travel asynchronously through Kafka without blocking the video stream. The complete journey is now clear. The request passes through the gateway and playback service. A manifest identifies the right CDN. The edge delivers small video segments, and analytics events follow a separate asynchronous path. This separation provides global scale, low latency, resilience, and a smoother viewing experience.